algorithm. The Kruskal algorithm starts by sorting all the edges in non-decreasing order according to their weight, and then iterate through each starting from the smallest edge, iterate through the following action. The check pick, pick the smallest edge and check if it forms a circle with the current spanning tree. If there is a circle, then we discard the edge. If there is no circle formed, then we include this edge into the new spanning tree. We repeat part 2 until there are all the vertices are included, or you can say there are v-1 edges in the spanning tree. Let's take an example here. First, we sort the edges by their weight. This will take E times log E time complexity. Then we enter the iteration. For each iteration, we will use the union find algorithm to determine whether the current edge forms a cycle with the current spanning tree. We pick the smallest one, and since the current spanning tree is empty, it will not form a cycle. Then we claim this to be the new spanning tree. Then we pick the smallest one again, this DE, and again FH. We iterate through starting from the smallest all the way until the largest. Let's look DH, alright. Here we discarded EF because if we include EF here, it will form a cycle, which violates the definition of a tree, so we discard EF. DG here, AC here. BD, we discarded BD because if we include BD, it will form a cycle with the current spanning tree. So we discarded BD. Again, okay, GI. Okay, this is not right. Since let's say ACBD. And GI should be fine, right? If we include GI, that should be fine, right? Alright, that's fine. So the whole algorithm runs time complexity. Sorting the edges will cost E times log E, and for each iteration we use the find union to determine the newly selected edge, whether the newly selected edge will form a cycle with the current spanning tree. This will take O log V per iteration, and we have at most E iteration because we at most have to iterate O through all the edges. So it is at most E iterations. So the total time complexity is sorting plus the iteration, which is E, the number of iteration, times log v, which is the time complexity for the fine union. But we know that the number of edges is at most v squared. So after taking a log, the two is in fact the same under the big O notation. So we can just simply write O, the time complexity for Kruskal algorithm, is E times log E.